same question as the previous ones where it says find the area enclosed by the graphs. And in this case, you would set 2x squared equal to x to the fourth minus 2x squared. And you're doing that to find what we can already see are the x values. There's 3 of them.
Mhm.
One at -2, 0, and then at 2. But let's see how to do them by hand. You would get everything on one side. So I'm gonna subtract 2x squared from both sides. And you have 0 equals x to the fourth minus 4x squared.
Okay.
Factor out an x squared from both terms. So that's x squared minus 4. This on the right here is difference of squares. And then you set each of these equal to 0. So you said x squared equal to 0, x minus 2 equal to 0, and then x plus 2 equal to 0. But because they're not testing that, like you don't have to show all this work. You can just say the zeros are at 0, 2, and -2.
Okay.
So this one is it's right on the edge of like something you could probably do without seeing the graph. Because if you notice, the blue is always underneath the red.
Uh-huh.
And you always do top minus bottom when you're integrating. So since the red is on top, if you did this in the wrong order, you would just get the negative of the correct answer. But you don't have to avoid, like there are graphs where it looks where there's multiple sections where they maybe come back. You got like this region, then another region.
Right. So what would be the top in that case?
It changes. So you break it up into 2 integrals. And I guess what I'm trying to say is like there could be an integral here from -2 to 2, and then another, I'm sorry, -2 to 0, and then another one from 0 to 2. But because the red is always on top above the blue, yeah, it's one integral.
Okay.
You don't have to make any changes here. All right, so the next step here is to integrate. We're going to integrate from -2 to 2. And then if you don't know which is the top function, again, like one thing you could do is check points between the zeros. So like, let's just check when x equals 1. So when x is 1, this first curve, you would get y equals 2. And for the second curve, you would get y equals 1 minus 2, which is -1. And that would tell you that the 2x squared is on top.
Okay.
But if you do it backwards, you just get a negative of the correct answer. So it's 2x squared, that's your top, minus your bottom, which is x to the fourth minus 2x squared.
So why did you need to find the zeros?
If you recall in the previous problems, because there's an assumption that there's an overlap. And if you find where they overlap, that you just find the area between those two bounds. But when there's 3, you've got to be more careful about whether the top and bottom change. But the reason you find out where they intersect is to find the bounds of the integral.
Oh, okay.
And see, the thing is that the more general question is here's 2 curves, find the area between them. And they give you 2 limits, and they have nothing to do with where they intersect. They could just be composition of them. So like for example, let's just say a curve, one looked like this and one looked like this, and I wanted it from, I'll just say that's 1, this happens to be 2, and then this is 4, and this is f of x, and this is g of x. So from 1 to 2, what is the top function? Do you see how it's g is the top function there? It would be g of x minus, and then the bottom function is f of x.
But then you have to do from 2 to 4, and where f of x is the top?
Exactly.
Oh, okay, gotcha.
Okay, and then it's f of x minus g of x. Now the thing is that like you might set them equal and figure out like where this point is at some point. Like there may be a reason to do that, but in the problems you're doing and the ones so far, the instruction's just been saying like there's going to be an overlap, and find that and then use that as your bounds. But you don't have to. It could just be more general. A to B, like 1 to 4 in this case.
Right, okay.
Okay, so going back to our problem, I do recommend simplifying here. So this is, this plus, negative, plus, so this becomes 4x squared minus x to the fourth. And then the antiderivative is 4/3 x cubed minus 1/5 x to the fifth, evaluated from -2 to 2. So this becomes 4/3 2 cubed minus 1/5 2 to the fifth minus 4/3 minus 2 cubed minus 1/5 minus 2 to the fifth.
Okay.
Okay.
And
And then we just got to evaluate it. Now let me just move all this down on my screen so we can just grab everything. I did not grab all this, get some numbers. I mean, you could go to your calculator if you're allowed to use it, but this becomes 4/3 times 8, so that's 32/3. And then 2 to the fifth is 32, so that's 32/5. And then inside here, this is -8, so it's -32/3, and then becomes +32/3. And then this one is -32, but with that negative becomes +32 over 5, but then it becomes -32 over 5. So that leads us with these two and these two. 64 over 3 minus 64 over 5. And I'm looking back to answer there. So you make denominators of 15 on both of them. So this one's times 5, what's that, 320 times 3, 192. So that equals 128 over 15.
a lot of work goes into one of these.
Yeah. Let me see if I can find another example here that maybe is a little easier for us to talk about some of the other things. All right, that one maybe we'll come back to. Have you done these in both the X and the Y axis or just the X?
We did them in both.
Okay. Yeah, so like, let me snip in one of these and see if this is something you're comfortable with. Here we go. Okay, so this one says, this would somewhere says find the area between the curves. And let's just verify where they intersect. We already know the answer is 0 and 1, but let's assume you weren't given the graph. So you'd have to set the y is equal. So it'd be 2y squared minus 2y equals 12y squared minus 12y cubed. And then I would just move everything right. Actually, well, I take that back. Let's go left because this is cubed. So let's move that. Let's add 12y squared or cubed. And then let's subtract 12y squared. So you have 12y cubed minus 10y squared minus 2y equals 0. And then you can factor out a 2y from everything. So that's 6y squared minus 5y minus 1.
So then that's 12y.
This we've got a factor here. We're trying to figure out where it equals 0. So 1 is at 0. Because you would set 2y equal to 0. So one of them's at 0. Yay, got that one. But this one you got to do some sort of factoring. I'll just try this one. That won't work, but this one will. So if we go -1 plus 1, that works.
Uh-huh.
So then you've got your other zeros. One's at y equals -1/6, and then y equals 1. But if we go back to our picture, they're specifying like, hey, it's between 0 and 1. So
it's only the
yeah, because you can
second
actually see like this is coming back, and this is going to end up like that's going to be at -1/6.
okay.
But there's a fair amount of work to figure out where they intersect, and you have to do it. You can't even proceed without it. So now the integral here is in your y direction, and it's right minus left. So your right function is this one. This is right. And then this other one is left. So that is 12y squared minus 12y cubed minus, that's this minus, 2y squared minus 2y.
Okay, and then
So we combine, yeah, looks like that becomes, oops. That becomes minus, and then the other one becomes plus. This is 10y squared minus 12y cubed plus 2y, yeah. And you're integrating from 0 to 1 because those are the bounds there. So it's 10/3 y cubed minus 3y to the 4th plus y squared, evaluated from 0 to 1. So that becomes 10/3 minus 3 plus 1. Whenever you get a 1, you just use the coefficients, and then 0 obviously cancels out. So this is -2, but we'll call that -6/3.
4/3.
4/3, yeah.
Okay.
So let me just snip one more thing in. We can talk about because we never really did one like this. We just talked about it, but this is the example where the question would ask you to find the area from -2 to 3 between the curves. And if you were to find the intersections, your intersections would be here at -1 and 0. So the way your instructor was writing these questions is the instructor saying, hey, just find the area between the curves, like just find this area that I'm shading in. But the questions could reasonably ask for it outside of them. So this one is actually
like from -2 to -1, you mean?
Well, or -2 to 3. Yeah, where you got to find that, other region. There's one from -2 to -1, plus from -1 to 2, plus 2 to 3. And the top and bottom changes each time.
Yeah. Okay.
And that's where you've got to be very careful about what the bounds are. If it just is to find the area between the curves, you only have to figure out where they intersect. But this is like an additional piece of information.
Okay.
I know I said, let me just one more here, because this is also kind of an interesting case to consider. So this question, it could say, find the area between the curves, but it could add in this little part and the x-axis. So it's this curvy region here. And the reason well, there's really two regions here, because on the left here, there's only a top curve.
Yeah.
And on the right, there's only a top curve. So there is no top minus bottom, but the bottom in this case is the x-axis. So on the left from 0 to 1, it's x squared minus 0, because x squared is your top and 0 is your bottom.
But isn't the x plus y equals 2 also your top?
When you're going from 1 to 2, it is, yes.
I see. Okay.
your top is now.
Because you
you
can't
saw-
have two tops. I see.
That's right. So you have 2 minus x minus 0. That's your top minus bottom.
Okay.
All right. So the question, I guess, is like, do you want us to do more of these types of problems? I can find some more if that's the case.
Maybe just like one that I do, and then we can move on.
Sure. Yeah, so let's go with something you haven't quite seen yet. Let's go with a sine curve looks like this. And then a cosine curve starts low. I'm sorry, starts high, comes down here. Let me actually draw a full period here. So did I get that right? Yeah. No, let's not do that. Let me find a different one here. Sorry, I'm just trying to come up with, like, there's so many here that to pick from. Just another moment here. Let's go. Okay, here's one. This one would say to find the area between the curves.
Okay, so how do you draw a picture for that? Oh my God.
So let's not draw a picture. Let's just solve it. Let's just set it equal to each other. Minus x cubed
Okay.
over 2 plus 2x squared equals minus x squared plus 4x.
2x squared equals minus x squared. Okay.
So we're gonna get rid of the fraction at some point, but let's
So like add the x squared over to the left.
yeah, and then we'll subtract the 4x. Okay, so that gives you minus x cubed over 2 plus 3x squared minus 4x equals 0. Multiply everything by 2 minus x cubed plus 6x squared minus 8x equals 0. And then you factor out a negative x because the leading term is negative. X squared minus 6x plus 8. And that gives you x minus 2, x minus 4.
Where's x?
So there are 3 zeros.
0, 2, and 4.
Yes. Okay.
Okay.
So the graph really doesn't matter. We just know that there's going to be an integral from 0 to 2, and then an integral from 2 to 4.
Okay.
So from 0 to 2, we should pick a number in between 0 and 2, like 1, and try it in both of these. So when x equals 1, the first curve up here is -1/2 plus 2. So that's 3/2. And then in the second curve, it's -1 plus 4, which is 3. So
okay.
So that tells you that the second one is on top. So it's -x squared plus 4x minus -x cubed over
So
2.
the second one is on top because it's a bigger number.
Yeah, because the y is bigger. Yeah. Okay, so that's your top minus bottom. And then you really do need to check the other one,
And why did you choose 1 to plug in?
because it's between 0 and 2. You don't want, if you choose the 2 endpoints, you'll get 0, but in the middle there will tell you which one is higher than the other. And it's a nice number.
Okay.
So from 2 to 4, you would choose maybe 3.
Okay, gotcha.
And I mean, it's not as nice, but it's still doable. For the first one, it's minus 27 over 2 plus 18. And then 18 is really 36 over 2. So this is 9 over 2. And then the other one is minus 9 plus 12, which is 3. So it switches the one on the first equation's on top, and then the second equation's on the bottom.
Okay.
Now a graph obviously helps but if you're not allowed to use Desmos or your graphing calculator, it's pretty tough. The technique I just showed you works pretty well for this.
So then you gotta do the
Yeah.
antiderivative, and I have to
Yes.
combine them.
You should combine first. Now we can stop here. Like we don't have to go through all this. We can if you would like, but the main thing is setting it up.
Right. So then, but you would just like on the left, you would just like combine like terms on
Yes.
the right, and then do the
Exactly.
antiderivative for both, add them together. Okay.
Yeah, and there's I mean, like setting them up is important. That's really what you gotta, like, if you're gonna spend time practicing, you can integrate some, but they want to know that you can do that.
Okay.
So if you do want to actually integrate one, I can give you a little easier one, or we can move on to something else.
Yeah, maybe like one easier one.
Okay. Yeah. All right. So this one, it appears to be more difficult than it actually is because of the fractions, but it's the same setup. It would just say to find the area between the curves.
Okay, so you start by just setting them equal to each other, right? So 3 squared over 2 minus 3x. So you move the 3 over 3x 1/2 minus 3. So then that's 3 minus 18. So you move the 3 over, and then that becomes minus 15/6, right?
I would have, okay, if we could just back up, I would probably clear the fraction. I would multiply everything by 2.
Oh, okay.
And that will, your answer will get to the same place, but let me just get caught up here. I subtract 6, so I would get x squared minus 6x minus 7.
Let me do that. So then 6 equals x squared. All right. So then that's x minus minus 7 plus, minus 7 and then plus 1. So then it's 7 and minus 1 are your zeros?
Yeah, that factors into x minus 7, x plus 1, which means that minus 1 and 7, which means that that's the bounds of your integral. And now you just got to figure out, well, what's on top and what's on the bottom. And to do that, I go back to the original curves here, the original equations. And, now you got to pick a number between minus 1 and 7 and like maybe 0.
So that's 0 over 2. So then that's minus 1/2.
Yes, and so how does minus 1/2 compared to 3?
Smaller.
Yeah, so 3 is on top, so it's
Top.
3 minus
Right.
the other curve there.
So then that becomes 3 is x squared over 2 plus 3x plus 1/2. So can I clear the fraction and then do the antiderivative, or do I have to do, no, I do the antiderivative.
I mean, there, you could actually you could deal with that. You could do something, but I would just keep it like this, where it's with fractions. You could like undivided, but it's not really the right way to do it.
3x minus x cubed over 3 plus 3x squared over 2 1/2 x. Oh, you combined the 3 and the 1/2.
Yeah, but it's 6 halves plus 1/2. So that, yeah, 7 halves on that.
Okay, so then that's different. Changes my answer. 7/2 x. Okay. Minus x cubed. So then that's 7 and -1. So then minus 7. 7 to the third. 7 times 7 is 49. 49 times 7. 343 over 6 plus 3 times 49.
That's 147 over 2.
2 plus 7 times 7, 49. 2 minus 1/6 minus 3/2. So it has. So then that becomes plus 1/6 plus 3/2 plus 7/2. Oh my god. Okay.
Yeah, sorry. I thought this one wouldn't have been as bad, but it's, I mean, it's just the fractions that are problematic here.
Isn't it minus -1 or -1/6? Because it's -1 that you're putting on top.
You're cubing -1, but then you're negating it after you're done cubing it. So it's
Oh, okay.
it's like that.
Gotcha. So there's that way. So that it's 342 over 6. 147 plus 49 minus 3 plus 7 plus 200 over 2. I feel like that's wrong.
Let me get a calculator out to check. It's
Wait, so does that become, when you combine like terms, so it's like 342 over 6?
which
and
one?
then-
The top, the top or the bottom? Which one do you want? I'm gonna both for you.
Well, don't you just at this point like add them and subtract them and stuff?
Yeah, I mean, I would probably like try to combine things in a nice way.
Yeah, so that's
like,
what I'm, so the ones that both have 6 is on the bottom. Like that's negative, oh wait, that's negative. So it becomes negative 344 over 6, right?
the bottom is, this is what the bottom combines to, and then the top combines to 245 over 6.
But can't you do the two, like, do you have to do them in top and bottom? Like, can you do
No,
the
you can combine whatever you want.
343? Okay.
Yeah, you can do as long as you come up with the right answer. Nobody's
Okay.
nobody really. And this one is probably too difficult to be doing by hand, because we're spending time on things that are not calculus.
Yeah.
So the rest of this, one of the next topics in 8.2 is using your calculator to do it. And then it talks about with respect to y, which we've kind of covered. This is probably a good one to do. So it says find the area enclosed by x plus y squared and f 4x plus y squared. If you want to continue down this topic, but I think this one, I wish I should have pulled this out earlier. This was a good one to do because it's with respect to y, or we can
Okay.
move on to 8.3.
No, we can do this one.
Yeah. So when I look at this, I notice there's a y squared and a y squared, and that means, oh no, I got to solve for x in both cases. So the first equation is x equals 3 minus y squared. And in the second equation, it's minus y squared divided by 4.
Okay.
So now you set them equal. Because when we're finding the area enclosed, we don't really care what the graph looks like. We just need to find the two bounds. 3 minus y squared equals minus y squared over 4. I would clear the fraction, multiply everything by 4. 12 minus 4y squared equals minus y squared.
You just set them, okay, and then that's move the y squared over.
Yes. Although, why did I do this wrong? It seemed like your instructor made this seem like it would get easier. This one isn't getting easier. But let me get to it. Well, okay, so we're gonna add y. Okay, I'm sorry, we're adding. No, this does work. Okay, we're gonna add y squared to both sides. All right, 12 minus 3y squared equals 0, and then you're gonna solve for y. So you get 12 equals 3y squared. Divide both sides by 3, you get y squared equals 4. So y equals plus or minus 2.
And y squared. Yep. Okay.
So as a result of that, you're going to integrate from -2 to 2, but with respect to y. Okay, now you don't know which one is right and which one is wrong here, like which is more right, which one is more left. To do that, you would set y equal to 0 because 0 is between these two bounds.
So plug in a 0 for both of those.
Yeah, so this first one is 3.
3 and then 0.
0, and you want the one that's, because it's right minus left.
Do you want the smaller one in front?
You want the larger x value first, so that like this should go in front. This 3 minus y squared.
Oh, so it's still like the top minus bottom.
It is, yeah, in some ways.
Okay.
Now, if you'll permit me here, I would like to actually switch this. Well, actually, let's just do it, and then I want to show you when you do it backwards what happens, so you can see as well. So this
y
is
squared plus y squared over, is that 4? Yeah.
Yeah.
Oh wait.
So we've got
Yeah.
1y squared, we've got -1, and we've got 1/4 here. So we got -3/4 y squared when you add them.
Oh, I see. Okay. And then you do antiderivative. So
Yep.
3y. Yeah. Okay. Minus, geez.
So you would put a 3 on the bottom, but there's already a 3 on top, so they cancel.
Okay, and then 2, -2. So then it's 3 times -2 minus 1/4 times negative
Do the top bound first. Positive 2.
2 cubed minus 3 times -2 minus 1/4 times -2 cubed. Okay, so then that's 6 minus 2 cubed is 8, but then it's minus 1/4 or times 1/4, so 8. Two, so then that's 4 minus, that's minus 6 plus 6. That's minus 8, and then it's times, it becomes +2, so minus 2. 4 plus 4, 8. Yep, I got the same thing.
Okay. So now let me integrate it the wrong direction so you can see what that does. Because I guess we never did that, and I think it's worth seeing.
Okay.
So I'm using I'm just going to an online calculator here to hopefully get a quick answer. Of course, it's not doing that. All right, let me try one more here. Why? Okay, let's see if this does it. Okay, so here is and you just have to trust the solution here, but when I do it in the wrong order, you get the same answer but negative. Okay, so this was the, and remember I just switched these.
Yeah.
And if you feel really good about your integration and you don't want to like think about the order, you can just choose the order and negate the answer if it's negative. Like you can just even put a negative out in front. But I probably wouldn't do that, but you could. Like you
But
could
like
totally.
when you like if you do it and then you get the like how would you know to do it negative? Like how?
Well, the answer is supposed to be.
Not.
We know the answer is +8. Like
Right.
if you, and that's what I say, if you trust your integration, like if you know I'm never going to make a mistake on this thing, like I'm really solid on it, you just choose the order arbitrarily. And if it's -8, you're like, well, it must be 8. And just move on.
Right. Okay.
And like,
but that's like in the case that there's not 8 and -8 as answer choices.
Well, okay, so sure, if there's multiple choice, but if I were for some reason someone gave me this problem, I would just do it in this order. I wouldn't think anything about it. And if I got -8, I would say, oh yeah, it's negative out in front, and then that's really 8.
Oh, so
and
if you get a negative, are you just saying like if you get a negative number that you always switch to positive, basically?
Yes, if you trust that you did it correctly, yes, yes.
Got it. Okay.
All right, so we've really done a lot on that topic. I would recommend some more practice problems, maybe the ones you have in Pearson, look at on your own, or the chapter review. But I guess let's go into 8.3 unless there's more to talk about.
We can go to 8.3.
All right. So I don't really like this. So let me just make one up here. These are, so there's these are the first kinds of volumes you might see. So let's say I tell you the curve is y equals the square root of x, and they tell you that the volumes are, let's go with circles with diameter like this. So this is the diameter right here.
Mhm.
So if you could imagine, let me see if I can draw this here. I know visually this makes sense, but it's like there are these circles, like they were smaller, they're getting bigger, and they're getting a little bigger, and this is following the square root of x.
Okay.
Okay, but that's their radius is when its diameter is like this. It's just like it's the circle looks like this, and then this circle here, which is really hard to draw. But these are like, they're like popping out of the screen. Don't like that. Let's try something different. Let's try. Yeah, these are hard to draw. So let's try it. Let's say they're squares with sides square root of x. So visually it's a square like that, and then there's another square like that,
Okay.
and then anywhere in here there's a square.
Okay.
Okay, so this is the first type. This is like type 1 of the problem you might see, where they give you a curve or they give you two curves, and they tell you that the distance from the axis to the curve or between the curves is something. It could be a side, it could be a radius, it could be the base of a triangle. Okay, we'll do that one next.
Okay.
But what you have to figure out is what's the area of each one of these shapes. Well, it's a square, so it's
Base times height.
and the base is square root of x, and the height has to match it, so it's also square root of x.
Oh.
So that's
So,
x. Is that okay?
yeah.
All right, now the volume is the integral of the area. So imagine you have all of these shapes. What is the width of each shape? The width of each shape is dx. So it's the area times dx. This is the width.
How do you know your bounds though?
I'm going to give them to you in a moment.
Oh,
I didn't give them to you, but this is key. It's central to this idea is that you understand that, and papers are probably like lining up papers is probably the best like way to like visualize it. Each one of these is a paper. It's got a width of dx. Like it used to be a paper.
right. So you don't know the actual number of dx. You just.
It's just a dimension of it.
Okay.
Because the dimension of area here is like units squared. So to get volume, you need another unit. You need units cubed. Or you
So
need,
is this the volume of one of those squares or all of those squares?
it's all of them. All of them. The volume of one square is just a times dx. But when you integrate, you get all of them.
Got it. Okay.
So we'll go from like 0 to 16.
And that has to be given.
Yeah, they have to tell you that. So this would be 0 to 16 x dx.
So then x squared at 16 and 0. So then that's 16 squared, whatever that is.
Yeah, 256 over 2, and then divide then have 128.
Yeah.
Okay, so let's do another one here. So let's pick another curve. I don't know if your instructor picked a lot of. Okay, so let's go y equals x, y equals minus x. Okay, and this time it's going to be a, what do we want to go with here? Let's go with a, did your instructor talk about the formula for an equilateral triangle?
Equilateral, yeah, we went over that, I think. Don't really remember it, but
Right, so the area of an equilateral triangle is square root of 3/4 sides squared. So in this problem, I'm telling you that because the side, so we're producing triangles now. So like this is and this is hard to draw, but it's like a triangle.
would they
And then,
ask you to draw these?
sometimes they do, but not really, because they're really hard to.
Yeah,
It's side between the two curves.
but so why can't you just draw like, why can't it just be like a triangle with one, like why do you have to draw these shapes basically?
Because you want to find the area of each shape and then multiply it by dx.
Oh, because we're doing the shape. Okay, got it.
Yeah, so the side length here, the side here is top minus bottom. It's x minus x. So it's 2x.
Okay.
So the area of the shape is 2x as the side, but because I'm telling you that they're equilateral triangles, somewhere it's the square root of 3/4, 2x squared is your area of each one of these triangles. And then I want it from, let's say, 0 to 3.
Do you not simplify that anymore?
We will,
Oh.
but it's the area of the shape times dx.
Right.
So
Okay.
like this is a key component to doing this, is to find the area of it.
But that's the area of one singular shape.
That's right.
Okay.
So this, like you just said, it's the square root of 3/4, but 2x squared is really 4x squared.
Uh-huh.
So it becomes square root of 3x squared dx integrated from 0 to 3.
So then that becomes, what's the square root of the derivative of square root?
It's just a constant.
Antiderivative.
It's just a constant. So that's just out here. It's 1/3 x cubed is your antiderivative.
Yeah, x cubed over 3.
Yes.
0 and 1. I mean 3 and 0. So then that's 3 cubed is 27 over 3. That's 9, and then times root 3.
Yep. So that's your volume.
Yeah.
Okay, so let me really quickly try one more here. So let's say I give you this curve y equals x squared, and I tell you this time that they're right triangles, right isosceles triangles.
Mm-hmm.
And you have to be told this if that's the only way you can do it. So the area of a triangle is 1/2 base times height. Your base though is x squared, but since your height, it's a right isosceles triangle, your base and your height are the same, so it's also x squared. So your area is 1/2 x squared times x squared. And then let's say I want the volume from 0 to 1. It'll be 1/2 x squared times dx.
So then that's 2x squared. Yeah.
Yeah, 1/2 x to the 4th, because you multiply, add the exponents. Okay. Then you find the antiderivative. You evaluate from 0 to 10. I'm sorry, 0 to 1.
1. So just 1/10.
Yes.
Okay.
We didn't do any circles or cylinders or anything else, but there's a lot of other stuff that we could
do next time.
Do next time, sure.
Okay, perfect.
And then you move into revolving around the x or the y axis.
Okay, I think I have 2 more lessons before.
Yes, we're gonna. Yeah, I'll see you on Sunday. Thanks so much for allowing me to reschedule with you, and I'll see you next time.
Thank you.
Have a great day. Bye now.
Bye.